Properties of exponents and logarithms. One property is the log base b of b to the x is x, and b to the log base b of x is also x. So if you see the log base 9 of 9 to the second power, well, that's just 2. 7 to the log base 7 of anything is the anything. So that's how they work. When you see these two numbers the same, you just get what's left over. These two numbers the same, you get what's left over. And then solving a logarithmic equation, remember, if you have the log base b of the answer equals p, log base b of a is p, change to exponential form and solve. So then you use the property of equality for logarithmic functions. So this is an important one. When you see that the bases are the same, that means the arguments also have to be the same. X has to be equal to y. Let's move that up a little bit. So that's that one right there. So here we have the log base 2 of 2x equals 3. Now here's the thing. What we've been when we've been solving equations, I've always asked you to make sure you know where that variable is that you're trying to solve for. So here the variable is locked up in the answer. If the variable is locked up in the answer, we have to unlock it, and if we're in logs and we need to unlock, we go to exponents and we rewrite the same equation using exponents. 2 to the third power is equal to 2x. So that's 8 equals 2x. Then we just divide both sides by 2, and we get x is equal to 4. That's it. So you can see what looks to be a very complicated equation. When you rewrite the equation using exponents or exponent form, then it becomes a very straightforward equation that you can solve. Let's go ahead and flip the paper over. Looking at number 14, we see so, like I said in the last example, identify where is the variable that you're trying to solve for. Well, the variable is over here. The variable is all by itself. It's not locked up in the answer, so there's no need to convert this logarithmic equation to exponent form. We know that the log base 2 of 32, well, that we should recognize that to be 5. And over here, I'll show you why that's 5. Remember, the log base 2 of 32 from our last lesson, if you just want to figure out what the value of that logarithmic expression is, you just set it equal to x. And you're really trying to figure out what is the log base 2 of 32 is the exponent that you have to raise the 2 to get to the answer. 2 to the power of x is equal to 32. And we know that 32 is 2 to the 5th, so since the bases are the same, the exponents have to be the same. And so, since you defined x to be the log base 2 of 32, and x is 5, we would say, therefore, the log base 2 of 32 is equal to 5. So we can replace log base 2 of 32 with 5. And the more you do these, the more you just look at that and you realize, okay, that's just 5 because it's the exponent that 2 is raised to get to 32. So we have that x is equal to 5/3. That's it. I would urge you to pause the video and try each of these problems on your own before you see me do them, because you may or may not be feeling okay about it, but maybe give it a try and put some thought into it before I do the problem. So anyway, we always identify in every equation where the variable is. Here the variable is locked up in the log, so we're going to unlock it by moving to exponential form. We have 2x being raised to the negative 2 is equal to 16. We know that 2x being raised to the negative 2 is the same as 2 to the negative 2 times x to the negative 2 is equal to 16. Not sure if this is going to be the easiest way to do this, but since I started it this way, I'll just go ahead and go for it. 2 to the negative 2 can be written as 1/4. X to the negative 2 can be written as 1 over x squared. And we still have equal to 16. I'm going to go ahead and multiply both sides by 4, and then I'm going to do the work over here. I've got 4 times 1/4. So I'm multiplying by 4 because then I get rid of the 1/4. So I get 1 over x squared is equal to 64. Well, in this case, I can rewrite that 64 as 64 over 1, and then I know that when I have a proportion like this, when one fraction is equal to another fraction, we have a proportion, and then we can just cross multiply. 1 times 1 is 1, and is equal to 64x squared. And now I'm going to go ahead and divide both sides by 64, because now I still need to solve for x. I'm trying to get x by itself. So I have x squared equals 1 over 64. So therefore, let's write it like this. X squared equals 1 over 64. And if I take the square root of both sides, I'm going to get x equals plus or minus the square root of 1 over 64 is 1 over 8. X equals, I didn't put the equal sign there. But here's the thing. If you remember in the last section, we always had to check our answers. We had to check to see if what we got maybe an extraneous solution. And in fact, our bases always have to be positive. So we're going to throw out the negative 1/8, and we're just going to go ahead and keep the 1/8, and that is going to be our answer. So as you can see, we check to see. I'm going to go ahead and do the next few in the next video. And I was going to say, we always check to see where the variable is. Just to review what we just did, the variable was not locked up in the log, so we didn't convert to exponential form. Here, the variable is locked up in the log, so we did convert to exponential form. And you can see you'll see what happens in the next video, but some of the ones we have to convert to exponential form, and some we don't, but we'll try to do plenty of examples so you can see when you have to do that and when you don't.